So in this lesson, we're going to take a look into another method, how to get the extrusion length from our bricks, but more precisely. And also we're going to rewrite our definition a little bit so that the top part of our wall is going to align exactly with the YZ plane, which is not the case right now. So this lesson is really focused on accuracy. We're first going to delete the part we did previously because we're going to rewrite it in a different way. And also the first thing we're going to do is we're going to make sure that these points, that the top part aligns perfectly with the YZ plane. If you look at our model, you see that I positioned our pavilion, the center line of our pavilion aligns perfectly with the YZ plane, and that's on purpose. But to make sure that the points that are close to that YZ plane, we're going to project those points on top of it. So let's insert a project component, project to plane, this one. And let's insert a YZ plane. Nice. So as you can see, now all the points are projected on the YZ plane, and the ones that are displayed on top of the red points, those are really close to the YZ plane, and those are the ones we actually want to align perfectly. So let's measure the distance with the original points with a distance component. And let's insert a smaller than component. And let's say if the distance is smaller than 1 centimeter, we want to use the projected point instead of the point that's within that margin. So let's insert a slider with 0.01, which is 1 centimeter. And let's insert a dispatch component to separate our original points and also our projected points. So let me turn off the dispatch. So these points are further away than 1 centimeter from our XY plane. So we're actually going to use those ones. And those ones, we want to replace them with the projected point because those are within the margin of 1 centimeter. So it's more or less like this. So let's merge these two lists together again to create one list. And let's reconnect it to our move component or effector component. And to finish up, let's also insert a clean tree component. So we remove any empty branches, which will help us later on in the definition. And we need to set the E to true. So let's insert a curve component to this one and simplify the outcome. And a point component. So let's do the same for the left side. So let's move these components a little bit to the right. And let's reconnect our components. And to finish up also the clean tree component. And let's simplify this output. So the next thing I want to show you is how to get the extrusion length information, but in a more precise way. And we're going to use a component for that called relative item. So let's insert this component. So this component is really nice because it retrieves a neighboring item from a data structure, which we'll see in a second is a really clean and nice way to retrieve the neighboring bricks and to know how much we need to extrude them in the end. Now before we start playing with this item, first I want to display the data structure we have a little bit better. So we're going to do that using a text 3D component. Text tag 3D, that's the one we want. Now the location is going to be our point. And the orientation will be the YZ plane again. And let's connect a point in the middle. Now the text we want to display, those are going to be our branches. And there's a nice way to retrieve the branches with a parameter viewer component. So let me connect a panel. So these are all the tags. Coincidentally, also the data structure we're going to use, but those are also going to be the tags for all our bricks. So these are the ones we want to be displayed. So the only thing is we need to graph the T input because it's a flattened outcome. Nice. So let's also set the text size a little bit smaller to 0.06, more or less. The color is fine, and the justification, let's set it to middle center. Let's zoom in a little bit. So this is how our bricks are ordered. So we first, in the left bottom part, this is our first brick, the 001. And then the column goes up. So 00, 01, 02, etc. until it reaches the top. 031, and then it moves to the next column, which is 10, then 11, 12, etc. all the way to the other side of our pavilion, which 4931 is going to be, that's the very last brick in the sequence. Now to come back to the relative tree item, just to show you how nice this component is and the power of it. Before you would have to do a lot of complicated tree and data structure operations to get to the same result. But now, just with this component, it will do it for us in a very easy and nice way. So the T, that's going to be the tree you want to operate on, which is going to be our point. So let's connect it to it. Now the offset, that stands for the neighboring item you want to retrieve from the tree. So let's insert a panel to it, which we're going to manually insert our offset we want to use. And the WP and WI stands for if you want to have the values wrap around its border, and their default is set to false, and that is what we want to leave them at. In a second I'll show you what it actually means and why we want to keep them set at false. So in the panel, here's where we're going to put our offset. So let's say I want to retrieve a relative item. Let's say I want to retrieve our right neighbor. So if I look at our 00 brick, let's say I want to retrieve the 10 brick, etc. For every brick, its right neighbor. So the offset would be +1, and a 0 next to it, because we don't want to go also up. We're going to stay in the same row. And this is also the syntax we have to use. So we use curly brackets and a semicolon to divide the offsets. So as you can see, nothing much has happened. Only the components turned from red to light gray. So at least that's something. So the A output is our original item. We inserted in our T, so that didn't change. But the B, that's the offset. That's the item that's relative to our offset we specified, our +1. Now if I connect a line to it, a line component, you see that it drew a line from, if I zoom in a little bit in Rhino, from our 0, 0 to our 1, 0 and so forth. And from 1, 0 to 2, 0, from 2, 0 to 3, 0, etc. All the way to the other side. Let's turn off our rectangles for a second. So basically those are horizontal lines. Now, if you remember, let me just zoom in here for a second. If you remember the WP and the WY, this means that it doesn't wrap around around the borders of the data structure. Because if you look at 49.0, for instance, that one doesn't have a neighbor that's to the right of it. So if we set the WP to false, it doesn't do nothing. It just returns the original value, let's say. But if we set this value to true, you see that it reconnected from 49 all the way to the other side, all the way to 0, 0, making a closed loop. It's basically the same values or the same wraparound value that's also available with list item, for instance. But we're going to leave it at false. So that's nice. And the nice thing of the offset is that you can insert multiple offset values. So let's say I want to retrieve the value that's diagonally to the right. So if I look at 0, 0 again, I want to retrieve the value that's at 1, 1. I specify +1 and +1. So +1 to go to the right and the other +1 to go 1 up. Oh, I need to set this list to multiple data line. And now you can see it also created a diagonal line, which is really cool. You can insert as much offset items you want to have. You can go pretty crazy with this. If I want to retrieve an item that's 5 offsetted to the right and 6 to the bottom, for instance, you can also insert these items. And let me insert a tree branch so I can show you the result maybe even more better. So let me turn them all off. So now I've selected the very first tree branch, which is 0, 0. So in 0, 0, we have a line that goes to the right and one that goes diagonally up. Looking at our offset, that makes totally sense. And for every branch, we have this pattern. So if I scroll a little bit to the right and to up, let's say I want to have our branch 6, 7 in that location. So column 6, row 7. We have the same offset applied. Now let's get back to the pattern we want to get in the end. If you picture the wall in your head, you notice that we have a diagonal structure where we have the checkerboard pattern, and one brick is always carried by 4 diagonal bricks that are neighboring it, let's say. So let's insert this offset pattern into our offset list. We already have one, which is +1, +1. If I do +1, -1, that's the other one. So now there's 2 remaining. So -1, -1 is the third one. And -1, +1 is the fourth one. Nice, so now I have a cross for everyone. I can move over the grid, as you can see in the Rhino canvas, and select any single branch, and it will show me the relation with the neighbors. And if I go down, for instance, to 13.0, you see that of course it can't connect to the bottom, and that was because of the wrap values we set to false. So now with the use of this component, we can retrieve very accurately the extrusion value a single brick needs to have, ideally. And in the next lesson, I'm going to continue using this method and translating the information we get from the relative tree item to translate that information into the exact extrusion length for our bricks. Thank you for watching, and I'll see you in the next lesson.